Hi, and welcome to ESPM 4295-5295. This is a second level course in GIS. It's a practicum course, sort of a soup to nuts project treatment over the course of the semester. So our goals really are to give you something akin to a real world work experience, taking a project from data definition and development through to report production. And there's a fair bit of analysis in between. We want to introduce the practice of setting up a workflow, to figuring out how do you go from a model, an idea of what you want to say or do, into a set of spatial data or a set of numbers that answer the questions you have. And so you'll learn new geospatial processing practice, putting together a lot of things you learn in the introductory course. And we'll have the undergraduates introduced to Model Builder and encourage you to use it through extra credit. And the graduate students will develop most of their work in Model Builder later on. For the undergrads, it's a writing intensive course. We want to improve their writing through a semester-long project and also introduce a tool called ArcGIS Online Story Maps that allow you to put together a report or a presentation that lives online. Now, because of the time we're in and resurgence of COVID, this class may be taken entirely in person or entirely online or as a mix. I know some of you won't want to come in because you're either immunocompromised or in contact with folks that are immunocompromised. I know some of you really prefer in-person learning, and we'll try and support both of those. We've been teaching online courses for 15 years in the intro course, and last year we developed and converted all of our materials to online for this course, so we feel we do a fairly good job. Now, there are mandatory participation days, a little less than half the days, but that participation may be either via Zoom or via in-person at the SCO Call Lab. We'll be running Zoom sessions during the SCO Call Lab, and all our lectures like this one are also online. But the mandatory participation here for there to make sure you go through the material at that time and you can get the answers to any questions you might have. If you come in person, a double layer mask is required over your nose and mouth at all times. We'll be inflexible in that. We'll have spares in case you forget yours. And if Andy and I are exposed, although we've both been vaccinated, we'll, as per CDC guidelines, move the course to completely online for 2 weeks if we know that we've been exposed through contact tracing or through somebody letting us know. Now, since the U really isn't supporting us much in this contact tracing, and their requirement for vaccination is pretty soft, they aren't doing really a hard check as near as I can tell until November, we're really relying on sort of the good faith efforts and honor system for you to let us know if you've been exposed or if you test positive. Of course, it'll all be confidential, but it'll make everyone safer if you cooperate in doing that. So thanks for keeping that in mind. Now, the trajectory is to install and get everyone acquainted with ARC. We're going to be doing a web access. Those that went through our 3131 class in the last couple of years, we've figured out how to do this pretty efficiently. And really the only thing you need is a fairly robust internet connection, faster the better, and a 2 to 4 year old or earlier computer. And you can run ARC on a virtual machine through the web. So that's a great development. But the key thing here is you need a fairly good internet connection. So you can run it from home or really run it from anywhere if you have a good internet connection. A reasonably recent computer will run ARC then mostly through this virtual machine and build skills, develop data, and go through various workflows, developing it slowly in pieces, and then answer a real kind of question with real kinds of data, meaning multiple runs to look at impacts of various conditions, which is often done with spatial data, and then basically summarize our results. So the 4295, this report, as I said earlier, will be a story map. 5295 will cover more tools. We'll have to turn in a report, but can be in the form of a presentation, a story map, or a short written document. The courses are similar. Graduates go into more detail on most topics, less writing, more higher level skills. For example, they have to delve into model builder in a much more complex way. Class pages define the schedule, and so they're these separate web pages we've set up. It's really too much to include in a good way inside of Canvas, so we only use Canvas really for turning things in. And the deadlines in Canvas should match the deadlines that we have listed here in these web pages. You can do a web search, if you don't remember this URL, for just CFANS GIS, and a dashboard comes up with the list of classes, and ours are listed here, the 5295 and 4295. Now, every week is a row. The rows are sometimes pretty tall, top to bottom, and then there's assignments on the left with things we're going to hand out in links, which are in blue or in red, depending on which class. Generally, the deadlines are listed here in the middle, and resources that help, either data or links to excuse me, links to videos or other documents in the rightmost column. So we go down week by week. The assignments are sometimes just completely described in that leftmost column, and sometimes there's a handout. So make sure you look for both. And again, the resources have many things, but usually they're a mixture of documents and videos, sometimes links to other websites. Now, how do we work these data? So we have an interesting computing environment. If you haven't worked on the cloud, and we'll eventually move everything to the cloud and pretty much all our computing, you have your computer, some fairly serviceable computer. You'll download and start this thing called Citrus Workspace Apps to Go. Now, there's an instruction set in that first week's work on the X295 setup that shows you how to do this. You basically have to download a couple of pieces of software, and then you can open it up, and it creates that virtual machine which shows up in your browser. You log on using your normal X500 that you use to sign in at the University of Minnesota, and it sets up a Windows machine through the browser showing up on whatever computer you have. Now, for the most part, people do this in a regular Windows machine or on a Mac, the iOS, but we've had people use a Chromebook, and I think somebody used a Linux machine once. All you need is a pipe in, and it will work just fine. Now, this Apps to Go basically creates a virtual computer, I'll call it a VM, a virtual machine, with its own C drive. You don't want to confuse that with the C drive on your computer, if that's what your computer names it. If you're working on a PC, the base drive is typically the C drive. On a Mac, it has a name, so there's going to be no confusion there. And so you have this that shows up on your computer, and data on the C drive are ephemeral. They go away when the computer goes away. We've set it up so there's also in cloud storage a W drive, and this doesn't go away between sessions. So the basic idea is that we'll work with all our data on the C drive, so we'll load it onto the C drive when we first start the virtual machine, and then start ARC and access from the virtual machine C drive. So we'll load catalog data and data layers from there. When we're done, the data we want to keep, the geodatabases that have our results, will pull back over to the W drive or to some other storage. We could pull them down to our computer, our local computers, because those drives will show up also. We don't want to leave them on the virtual machine C drive, because when we close that virtual machine, all the data on it goes away. The W drive, your local C drive, or another drive I'll talk about in a second, is where we want to store our data. We need to deliver data to you, some fairly large data sets, and so we have what's called the CFANS L drive, or our main data drive. So we'll refer to this in the various weeks on finding the data on the L drive. Now, there's a 4295 workspace there. It's ESPM 4295, and the 5295 workspace, basically a directory there. We're going to give you data through those directories. It should be read-only, so you go and you drag the data from that L drive to your W drive or to the C, except if you drag it to your W, then it's permanent between sessions, and then you use those base data to create your own data or as an image background or for other things. So there's the L drive, which we use to deliver data. You can also consider archival storage. There's 2 directories for each of the classes. We have a 4295 share and a 5295 share. And you can go in those and then create your own directory and store your own data in there. You want to store your data in multiple places. So the W drive will last at least through the semester, maybe a little bit beyond. The L drive is there for a couple of years. And then there's your own computer. So you want to make copies, save them to these various locations really each week. Save the L drive one week, your computer the next week, the W drive the next week, and somehow identify those. You don't want to go longer than a week without saving data, and some people towards the end are saving data every couple days because you hate to redo the work, right? So every once in a while you want to archive store data on your hard drive or on a USB drive, right, or both. So make sure you have some backups that are not too old of all the work you've done. Right? Apps to go, it just looks like this. Again, we have this X95 documentation set up, and so you'll get a window inside your browser that looks like a Windows machine, and it's a virtual Windows machine running off in the ether, right? Again, Andy has set this up with documents that walk you through this in videos. You can also go to the IT.umn.edu and look for apps to go. There'll be a lot of information on how to download and how to use the data there. How to install the Citrix workspace with apps to go is pretty straightforward. Now, once you download it and install it, you start it by clicking on the app, and it will either start up directly or it'll download a file that you have to click on. Now, this downloaded file goes to where your default downloads are, and when you click on it, then it'll eventually get you to a login page, and you use your X500 username and password, which you use for all your UMN accounts, and then you'll get a screen that has basically their favorites or desktops, and you click on the desktops. Right? So this lists then a set of desktops, and we'll tell you right now it's named the CFANS Cloud Desktop, but they may rename it. So we'll give you a last minute heads up on what they'll name this thing. I'm making this video a week in advance. And then if you click on that CFANS Cloud Desktop, it will start up your virtual machine. After a while, you'll get basically a W and a link to the L drive. If you start with these desktops and it doesn't have all the drives, you probably started the wrong one, so you need to get out of it and figure out what the right one is. Right? Okay. Now, as an alternative, and it's not recommended, but we mention it because some people just can't come in, don't have a fast Ethernet, or don't have a reliable Ethernet connection, but they have access to a fast new computer with lots of memory. You can download ArcGIS and do a full install, and then use this VPN software to download the data directly from the L drive back and forth. So you can work alone, essentially, on your own computer in the old mode we used to always use. Once then you've installed it, use the VPN, you have to map the drive to these target folders. So I'm just going to go through this quickly. It's here for those few folks that might want to do this. They can come back and refer to it, but most of you won't do this and don't need to pay much attention to it. There are operating system specific instructions on how to do this download in VPN. And then from the Mac, you can use this File Explorer to drag files back and forth to your UMN. Now, there's this CFANS drive, again, that L drive that lives up there. It's files.umn.edu, the CFANS drive. That's the drive that we will access from inside the computer lab. If you come to the lab physically, the CFANS L drive shows up, and that's then basically how you work with it. Now, again, a bunch of information here on connecting to the L drive we're not going to go over. This is just for those folks that have to do it through the VPN. Okay. Our project is this rainfall mitigation in the St. Paul campus. So this is really a very current topic. With climate change, it's raining more with more development. We're getting more impervious surface, so we're getting significant flooding and water quality degradation because of runoff from hard surfaces. So municipalities are doing a lot of things to try and reduce runoff by making things like pervious pavement that lets water flow through it, by putting in rain gardens or catch basins or underground storage or underground filtration. All these things to try and keep downstream flooding from getting bad and downstream water quality from getting bad. So we're going to work on this within the St. Paul campus for 2 watersheds. We can get this done in a semester. It's a current, interesting topic. It requires multiple levels of spatial data analysis. It's doable within a semester, but not so easy for most of you that it's something that you can finish in less than 10 or 12 weeks. It's going to be a lot of work for a lot of you folks, so plan on spending a lot of time on this. The 2 watersheds then here, both at the north end of the campus, basically one that includes Green Hall, the building we're in, and then one just to the south goes down near the student center and out by the parking ramp and towards the vet school. Now there's separate practice areas we develop data on here at the start. So we're going to do analysis in these watersheds, our whole analysis, and we'll give you the data for those. But you'll develop the same kind of data for these 2 practice areas for the undergraduates. For the graduates, they'll just use one of these practice areas. The reason we have you do this is that some folks mess up in the data development, and we don't want that to handicap folks later on when they're doing their analysis. We all start then on the same page. This course, whereas the first course that we taught, the intro course, we're down here in sort of remembering and understanding and a little bit of application of GIS. These courses are higher up on Bloom's taxonomy. You have to do some higher level analysis and evaluate what's the best way to do things, judge the relative value, and then do some novel combinations. So this course is fairly high level. So this week you need to review the course website, read the overall project description, not too closely, but just scan it and get the gist of what we're going to do. Install software, however you need to install it. Become familiar with transferring files between the various drives. Create a geodatabase, digitize and reacquaint yourself with ArcGIS. So we're really just getting the house sort of framework set up so that you don't have to worry too much about getting access to the tools. That's what we're doing this week, is getting a vague idea of what we're doing in the future, but really making sure that you can develop a geodatabase in this virtual machine and save it back to your long-term storage. Okay? So there are all sorts of help here, videos on how to install Citrix, how to do various things, and on digitizing or how to create a geodatabase. So some of these we pull from the 31, 31, 51, 31 class. Some of these we developed specifically for this class. Remember, in the 4295 you have 2 areas. One's for buildings, the others for trees. You're going to be able to be basically doing 2 different digitizing projects in the future. Mostly what you're doing now is just doing the outer boundaries, right? Digitizing the boundaries. Use this as a guide, and we show you how to use either the campus images we talk about it or a web map and service. Again, this should all be review, although it may be a while and you're rusty, so you can look at those review materials and digitize these 2 boundaries to turn in. All right, 5295, it's a different area, and again, in your materials there's a different map that you're referred to. We want you to digitize this area. We have you do 2 versions of it from 2 different image sources to show you the kind of variability you get with supposedly high quality, high resolution image data. We want about 1 meter accuracy, a little less in this kind of analysis, and this just shows you how you get differences in the data from different sources. So that should get you started. We'll talk about this in class too.